Today we are going to talk about how we're going to solve inequalities by multiplying or by dividing. So this, when you title this, you're going to title it as Solving Inequalities by Multiplying or Dividing. So write that down. Solving inequalities. And so when you're solving inequalities by multiplying or dividing, we need to see that something special happens. And that special thing has to do with when you multiply or divide, sometimes your inequality symbol has to turn over. Okay, yes?
Wait, are you recording right now? Can they see me?
They can't. It's just a screen recording. So now they're hearing me explain to you that it's a screen recording, so they're seeing this. So let's take an example. For example, we all know that 2 is less than 5, right? So 2 is less than 5. So when you multiply the same thing times both sides, like for example, if I multiply sides times 3, okay, I'm going to get 6 on the one side, I'm going to get 15 on the other side, and it still stays less than. Okay? However, if I take 2 is less than 5, and let's say instead of multiplying by 3, let's say I multiply both sides times -4. Okay, so I'm still doing the same thing to both sides of this inequality. I've multiplied this side times 2, and I multiply this side times 5. And what I get over here, -4 times 2, is -8. And over here I get -20. However, what is greater, -8 or -20? Go ahead. -8 is greater. So look what happened with the inequality. I multiplied by a negative number and it flipped the inequality upside down. That's going to happen any time that you multiply both sides of an inequality by a negative number. If you multiply by a positive number, it's going to stay the same. It doesn't matter. You can also start with negative numbers involved. So for example, if I take -1 is greater than -5. Oh, somebody said 25. We can do that. So -1 is greater than -25, so that's a pretty obvious one. If I multiply both of these by a positive number, such as 5, sure, we'll multiply both sides by this positive number. I take 5 times -25, and I take 5 times -1. 5 times -1? -5, and 5 times -5 is -125. So which one is greater? -5 is greater. Notice that the inequality sign stayed the same. Even though I multiplied both sides by a positive, we started with negatives. That's fine. It doesn't matter what you start with. It matters what you multiply both sides by. Same thing here. If I did -1 greater than -25, and I multiply both sides by a negative number, -6, sure. -6 times -1, and -6 times -25 gives us 6. And then this one, negative times negative, gives you a positive. 6 times 25, if you think about money, if you think about 25 cents and you have 6 of those, you know that that's $1.50, right? So 150 cents or 150. And notice what happens. The sign changes. So really important, the same thing happens if you're dividing both sides by a positive, it stays the same, but if you're dividing, it flips over. And we use those ideas in order to solve inequalities and graph them like we did before. I'm going to start a new page right here so that we can look at things. This is the part right here that's important for you to write down, because we need to make sure that you guys are able to solve inequalities. So for example, if I had 3x is less than 9. Sorry, 3x is less than 9. Sorry, thinking about. We'll fix that up, make it a little neater. 3x is less than 9, and you want to solve this. You want to get x by itself. What do you do to both sides? Yes? We're going to divide both sides by 3, yes. Because you need to undo the multiplication. So when I divide both sides by 3, over here, 3 divided by 3 is how much? 3 divided by 3 is 1. 3 divided by 3 is 1, so this is 1x. 9 divided by 3 is 3. X is less than 3, and when you graph that one, we have 3. It will be an open circle, you're right. And then it goes to the 1 direction, because 1 is smaller than 3, so we're all the way over here. Okay? Now, here's the other thing. If you had another one, let's say I had negative 2a, and that negative 2a is less than 8, and I want to solve this, I need to, what would you do to get the a by itself? Yep. Divide by negative 2, but here's the thing that we do. When we do this, because I divided by a negative, you have to flip over the sign. Flip the inequality, write that down. Anytime you multiply or you divide by a negative, in order to solve it, you have to turn that inequality over. And so your new solution is greater than negative 4. And the greater than negative 4 would be this way. The way that the negatives work whenever you multiply or divide both sides of an inequality by a negative, it turns that inequality over. It makes it backwards. So we need to make sure that you remember that. It works for multiplying, it works for dividing. If you multiply or divide by a positive, then it stays the same. If you multiply or divide by a negative, it flips it over. That's really the only change that we have from what we were doing when you add or subtract in order to solve an inequality. Let's look at another one, brand new one. So if I had x divided by 2 is less than 3, when I have x divided by 2 is less than 3, what do you do to both sides? Actually, this one's different. This one we don't divide, we multiply by 2. In order to undo division, you multiply. All right? So we do times 2 on both sides. 3 times 2, because divided by 2 times 2, it cancels out. Our inequality comes down and stays the same. And we get 6. If we had the same type of thing, but say we had negative 4, and I need to multiply both sides by negative 4, and since I multiply by a negative, it means I have to flip over the inequality. So x would be greater than negative 12. And that's really the whole heart of it. You know what to do because of the equals ones. But if it's negative, if you multiply or divide by a negative, it flips over. And if you multiply or divide by a positive, it stays the same.